Hello everyone. Today we are going to talk about the Atmega 808, 809, 1608 and 1609 series of microcontrollers. Basically, this is a new series of microcontrollers from microchip, and there are also some other variants of microcontrollers with the same megaAVR 0 series, which is Atmega 3208 and 09. These microcontrollers comes with a new kind of Arduino board, which is the Arduino Nano Every board. Arduino Nano Every is a new series of Arduino which supports this megaAVR 0 series microcontrollers. This microcontroller is basically 8-bit AVR but built with a RISC architecture. Today I am going to start with Atmega 808 microcontroller, and we will see how it can be programmed from an Arduino board. I had installed the board support for these microcontrollers, and the code which I installed from the board manager. I used the board from this board manager and MegaCoreX series. This board support include support for Atmega 4809, 4808, 3209, 3208, 1609, 1608, 808 and 809. When you select your microcontroller, there are other options available which you can modify, like the internal 16 MHz oscillator is by default selected. You can also select the other internal oscillator options like 20 MHz, 10 MHz, 8 MHz, 5, 4, 2, 1 and so on. You can also select the external oscillator options, but I think to use an external crystal with these microcontrollers seems a bit pain, and we should stick with the internal oscillator because it also comes with a minimum hardware pins required to set up. And if you noticed, I had attached this LED to the pin number 1 of this microcontroller, which is the digital pin 7 for this Arduino series. And if I upload the code, you will see an LED is blinking. You have also an option to change the BOD, which is the voltage level detection, and you can also choose the EEPROM or the pins standard of 28 pin standard or 32 pin standard. You can also use a pin, external reset pin, as a reset or GPIO. You can select a bootloader or no bootloader option for these microcontrollers. Because this microcontroller comes with a very latest and powerful architecture, it also supports multiple UART, and you can configure the UART on the alternative pins as well. Other than that, you can select a COM port and the programmer. I would like to mention that I had find very difficulty to figure out which programmer should I use for this microcontroller? Because this microcontroller supports UPDI protocol, which is a one-wire protocol, although the Picket 4 supports this protocol, but for now I don't have Picket 4, so I do have an Arduino. So I searched online and find out that JTAG to UPDI is a good option. I reprogrammed my Arduino Uno at mega328P microcontroller to this JTAG to UPDI hex file. After that, the pin number 6 of the Arduino Uno is used as a UPDI as mentioned in the GitHub. If you go back to this microcontroller datasheet, it says that it is a part of megaAVR 0 series, which use the AVR processor with hardware multiplier running up to 20 MHz, which is more than enough. And at the overview, if you come to the overview section of megaAVR 0 series, you may notice that it supports flash memory from 8 KB up to 48 KB. And the 8 KB series comes with the ATmega 808 and 809. The 809 series is 48 pin, and the 808 series supports 28 and 32 pin configurations. And if you come with the 48 KB option with the ATmega 4808 series, it also supports 40 pin and 48 pins, but the ATmega 3209, 1609 and 809 all only support 48 pins. So this was the basic overview of this megaAVR 0 series microcontroller. Coming down, you may notice the different variants of this postfix after the ATmega series. Let's talk about the device designations or the naming conventions of this device. The first AT and the Mega denotes that it's an AVR product family. The 48 will describe the flash size in a KB, and if it's an 8, it's a 8 KB, and if it's 48, it's 48 KB. And the next 0 series denotes that it's a Mega 0 series, and the next 8 or 9 could denote the PDIP 40 pins, and if it's a 9, it's a 48 pin, which is a PDIP 40. And if you if you buy the package in a PDIP format, it will comes with a 40 pin, and if you buy ASOP or a different variants of SMD, it comes with a 48 pin. And if there was 8, it will be a 32 pin, and if you buy in a ASOP, it will be a 28 pin. After that, there are different postfix, which could be MFR. If it is the first letter, it is a package type. It could be A, M, P, or X. A denotes TQFP, M denotes QFN, P denotes PDIP, and X for SSO. And the F will be the temperature coefficient, which could be -40 to 125 or +85, and it could be F or U. And the next thing, R, is a carrier type. R denotes for a tap or a reel, or a blank could be a tube or tray. So there could be an R or there could be nothing. And the VAO suffix is a variant suffix. VAO denotes the automobile, and the blank denotes that it supports the industrial kind of applications. So here is a memory overview for this series. So you may notice that the chip we are using 808 comes with 8 KB of flash, 1 KB of SRAM, and 256 bytes of EEPROM and 32B of user. And we also have a chip of ATmega3208 series, which comes with 32 KB of flash and 4 KB of RAM and 256 bytes of EEPROM. There are peripheral overview of this series, and you may see that maximum frequency it supports 20 megahertz. There is one 16-bit timer counter, which is TCA, and 3 type B timer counter, and there is one real-time counter or RTC as well, which is a very good feature for latest microcontrollers, which they should have. You may also see that it has built-in 3 UARTs and 1 SPI. After that, you may see that it has a I2C, one I2C or a 2-wire interface protocol, and 1 ADC, and there is no DAC, and the AC inputs are 1, and there are GPIOs of 23 GPIOs, port A, port C, port D, and port F. So these are, and for the programming it supports UPDI. These are the main options that we could find out from the datasheet. One more thing, which is the CRC, which is a code memory scan hardware. It is optional automatic CRC scan before code execution is allowed. And watchdog timer, obviously, but the external interrupt is on all general purpose pin, so you are not limited on few pins in the case of previous Arduino microcontrollers like ATmega32 or ATmega328. You are not limited to 2 pins. You could use external interrupt on any external GPIO pin, so you are not limited to few pins. You can use external interrupt on all pins. Literally, excuse me for this background noise. And moving on, if you come down, there is a block diagram of these microcontrollers. You can scroll this, and here is a pin configuration of 28 pin ASOP. So this is the configuration that we are using. We had attached a LED on PA7, which is a 1 pin number 1, and you may notice that all you need to do is put a ground on 21 pin, attach a positive 5 volt on VDD, and for pin number 19 you can use that for UPDI program uploading, and optionally you could for the ADC external positive supply, you can attach a positive 5 volt on pin number 14, and you can give a ground on pin number 15 as well. So if you are planning to use an external crystal, you have only 1 pin option, which is pin number 22, which is also used for PA0. So that is the pin which is used for the external clock, and these are the only minimum setup that you need to do for this microcontroller. Moving on, you may come to the JTAG to UPDI hex file. Download this hex file and upload on your any Arduino Uno or Arduino Nano or Arduino Pro Mini, whatever setup you may find feasible for this, and you are good to upload the sketch on the your microcontroller. The JTAG to UPDI repository comes with all the build file and source code for building this hex file, and here are the pin connections which you need, and you need a 4.7K resistor. I'm using a 1K resistor. I'm using a 1K resistor instead of this 4.7K resistor between the PD6 and UPDI pin. And if you install the board support for MegaCoreX series, you are good to program your microcontroller from the Arduino IDE as well. Otherwise, all you need to do is to change this AVR configuration file in your AVR installation setup or the folder, and you will get the option to communicate with the UPDI via this command. And these are the commands you may want to explore, and this is the repository which I used. I tried to use the Pi UPDI GitHub repository, but somehow this wasn't working for me. And if you find it Pi UPDI library working for you, please leave the method and in the comment section. Maybe some other person will get benefit from it. And that's all for this repository, and let's move back to the Arduino. And all we need to do is to select our microcontroller and let all other things as default. Just change the programmer type to JTAG to UPDI, and make sure you select your Arduino Uno COM port. And after that, write a code like this. You may notice a little change. Digital write fast method. You can use the digital write method as well. There is no problem. But the digital write fast comes with a 1 instruction beneath, so I'm using the digital write fast function instead of that. And let's change this delay to 500 instead of 500 millisecond instead of 1000 millisecond. And let's try to upload the code. Go to the tools, go to the sketch menu and upload using the programmer. And here you may notice, and down here it is started compiling the code, and after compiling the sketch, it will try to upload the sketch onto your hardware via JTAG to UPDI interface. And it may take a little time depending on your machine. Now it is uploading the code, and the uploading is done, and the LED is flashing faster than the normal it was doing before. So that's the all setups to get started with this microcontroller. All you need to do is to add a board support package and flash JTAG to UPDI hex file in your Arduino Uno. Just use D6 pin. On the UPDI pin, use a 1K or 4.7K resistor in between, and you are good to upload the code. And here is an LED is flashing, and that's the microcontroller which I'm using. So that's all for today's lecture. See you in the next one. Thank you.